Good morning students. Today we are going to see about Lagrange's theorem using design thinking approach. So we know about the 5 stages of thinking. What are the 5 stages?
Empathy, define, ideate, prototype,
and test. So now we are going to explain about the empathy part.
So for empathy, a student wants to know why the order of any subgroup must divide the order of the whole finite group. Intuition demands the subgroup sits as equally sized block inside the group.
Next stage is define. So anyone?
I should proceed define. So Lagrange theorem I do. If G is a finite group and H is a subgroup of G, then modulus H divides modulus G. Equally, modulus G is equal to G into H, G of H dot modulus H, where G of H is the number of left quotient of the H in G.
And the idea of this Lagrange's theorem is partition G into disjoint pieces with left quotient each the same as H. If the partition is into K equal to size in terms of size, modulus of H, then modulus of G equal to K. Modulus of H, so modulus of H divides modulus of G, we will define left quotient GH is equal to GH is to H and show quotient partition G. Show each quotient has exactly modulus of H elements, count quotients to conclude divisibility.
Prototype. Let G be finite G less than or equal to G for any G belongs to G. Define the left quotients. G of H is equal to Hg is to H belongs to H. Every element of the group G belongs to the one and only one quotient of the subgroup H. These quotients do not overlap and each quotient contains the same number of elements as H. If there are k such quotients, then the total number of elements in G is equal to k times the number of elements in H. Therefore, the order of H divides the order of G.
Next, let us see the test part of this problem statement. First, let us take a concrete example. Let us take group G, which has a modulo of 12 under addition, Z12, and order of G is 12. So the values of Z will be from 0 to 11, which contains of 12 elements. Let's take the subgroup of H, which has 0, 4, 8 values. Then the subgroup of H is 3. So the left quotients, we have to add the order of H with 0, 1, 2 and 3. So using Lagrange's theorem, according to Lagrange's theorem, the order of H must divide the order of G. So order of H is 12 and order of G is 4, which will be the final answer.
Okay, let me conclude this. So overall view of Lagrange's theorem by design thinking approach. So here the first stage we have found is empathize. So what do you mean by empathize? The whole finite group is divided by the order of the subgroup G. And define is nothing but we are defining the statement that is G is a finite group and H is a subgroup. Then order of H divides order of G. This is the statement. And finally the ideate part is nothing but we are proving this theorem by using coset method. That is we are partitioning the group G into disjoint pieces, that is left coset or either right coset in each of the same aspect, and the partition is into K equal size blocks of size order H. Then order G is nothing but K into order H. So that we are proving by one example. I will tell you later. So order of H divides order of G. So the first step is defining left coset, that is G into H is nothing but GH, where H belongs to the subgroup capital H. And the second step is we are showing how cosets are partitioned into the group G. And the third one is we are showing each coset has exactly H elements. And the fourth one is count cosets to conclude divisibility. So these are the steps involved in ideate part. And the fourth stage is nothing but prototype. Here we are defining the finite group H G and subgroup H, where G belongs to G is given by GH is equal to GH such that H belongs to H. So here every element of the group G belongs to one and only one coset of the subgroup H. So these cosets do not overlap and each coset contains the same number of elements. So if there are k such cosets, then the total number of elements in G is equal to the k times the number of elements in H. Therefore, the order of H divides the order of G. Let me tell you through this example. Suppose if you are considering a group G as addition modulo 12, that is Z12. So Z12 is nothing but it is an integer group involving 12 elements. So starting from 0 to 11 of the elements. So Z12 equal to 0 to 11. So here we are taking one subgroup H. So that contains 4 elements, 3 elements, 0, 4 and 8. So order of G is 12 and order of H is equal to 3. Here our claim is order of H divides order of G. So that is 12 divided by 4 equal to 3 cosets we are going to find. So I am writing the coset H to be 0, 4, 8. When we are considering the left coset, we have to add each element of H with each element of G with the H group. So 0 plus H is nothing but 0, 4, 8 and 1 plus H is nothing but 0 plus 1 is 1 and 4 plus 1 5 and 8 plus 1 9. Similarly 2 plus H is nothing but 0 plus 2 that is 2, 6 and 10 and finally 3 plus H is nothing but 3, 7, 11. When you notice this, these every order consists of only 3 elements. So the order of H is nothing but 4, but 12 divided by 4 that is 3 cosets each one is having. So this is our using an